Alright everyone, so good afternoon. Hope your day is going well so far. Today we're going to talk about polynomial long division, and this is an Algebra 2 topic, so you might recognize it from last year, but it'll be important when we talk about partial fraction decomposition as well as other topics in this polynomials unit. For you to do now, I want you to divide just this simple long division problem. So not polynomials just yet, but you're going to see it's the same algorithm. So 31,673, divide that by 5. I'll give you all a minute to do so, and then we will discuss. Okay, so let me pause you here. So let me scroll up for the answer, and then if I can get a volunteer to go through the solution. So the final answer was 6,334. That's the quotient, and the remainder is 3. You could also write this answer as 6334.6, right? Because 6334 is the quotient plus 3 over 5, that's 0.6. All right, we have volunteers to go through this long division. All right, we'll go to, oh, sorry. So I'll Salu's hands first, and then we'll go to Sam for the next one.
So basically what we did was we saw how many times the 5 went into the first number, and since in this case it didn't, we decided to take the first two numbers, which was 31 and 5 goes into 31 6 times, so we put at the top and then multiply that 6 by 5 to get 30, in which we subtract that 30 from 31, which leaves us with 1, and then we bring down the next number in the actual number, which is 6, and then we see 5 goes into 16 3 times, so we put that number next to the 6. 3 times 5 is 15. We subtract the 15 from the 16, we get 1 again, and then we bring down the 7 as well, and then we see that 5 goes into 17 3 times, and then we multiply by the 5 times 3, which brings you 15, and then subtract 15 from 17, which gives you 2, and then we bring down the last 3, which is 23, and then 5 goes into 23 4 times, so we put the 4 at the top next to the 3, and then 5 times 4 is 20, and we get a remainder of 3, which gives us our answer 6,334 of a remainder of 3.
All right, thank you for that. That was well explained. So the quotient is 6334. Again, the remainder is 3, as Salu explained. And you're going to see that this is the same exact procedure or algorithm for polynomial long division. And, a few differences, but you're going to basically divide this by the divisor, in this case 5, and then multiply that number, 6 times 5, subtract, and then repeat the process. Okay. All right, I'll give you a sec to copy this if you need it, and then we'll move on to just some follow-up questions regarding this, and then polynomial long division. All right, anyone still need to copy this? All right, I'll move on. All right, so just some terms regarding this. You don't have to copy this. I'll actually summarize this in the notes for today. But just some terminology for long division. For terms, that we'll see later on. Divisor, dividend, quotient, remainder. Here 5 is the divisor. That's what you're dividing by. So we're dividing by 5. 31673 is the dividend. That's what we're dividing. 6334, that's the quotient or the answer. And then 3 is the remainder. And something you should notice about the remainder relative to the divisor is that the remainder is less than the divisor. Right? It makes sense, right? Because if the remainder was greater than the divisor, let's say like it was the remainder, or the quote unquote remainder is 6, then we would keep dividing, right? So the remainder has to be less than the divisor, based on just how the procedure goes, right? We keep dividing until the number that's left is less than the divisor. So 3 is less than 5, so we can't divide any longer. Okay. All right. But yeah, with that being said, let me move on to polynomial long division. Just a quick overview of the rest of the lesson. Here's just a problem with that, and then we're going to talk about the division algorithm, and then if we have time, we'll go to this group work question. Okay. All right. So polynomial long division, you're going to see it's the same procedure. Okay. So here it's 8x cubed minus 3x squared plus 2x minus 1. We're going to divide that by x plus 2. And here they want us to identify the quotient and the remainder. Okay. So we have 8x cubed, right? So one thing that is different about polynomial long division is that you only actually look at the first term, so the leading term in the divisor. So in this case, the divisor is x plus 2, right? So the term that we are going to divide by, though, is like x. It's just x. So we first have 8x cubed, divide that by x, we get 8x squared. Then we're going to have 8x squared, multiply that by x plus 2, we get 8x cubed plus 16x squared. Okay, we subtract that, and then we're going to end up with negative 19x squared. We're going to bring down the next term, which is plus 2x. Okay, and then from here, just like the algorithm for the do now, right, we divide the next term. In this case, it was 16, right? Divide 16 by 5. In this case, we divide negative 19x squared plus 2x, divide that by x. Okay, that's going to be negative 19x. Then we're going to subtract negative 19, the product of negative 19x and x plus 2. So negative 19x times this is negative 19x squared minus 38x. Subtract that, you're going to get 2x plus 38x. That's 40x, and then bring down the negative 1, you get 40x minus 1. That's going to be followed by 40x divided by x, which is plus 40. So we do 40 times x plus 2. Subtract that, you get 40x plus 80. And you're going to get negative 81 as your remainder. And negative 81 has a lower degree, right? So this is technically like negative 81 x to the 0. And we can't, x, we would consider that to be larger than negative 81. Okay. So yeah, that's where we're going to stop. Negative 81 is less than x, right? So quotient is 8x squared minus 19x plus 40. Remainder is negative 81. Okay. Note here that, yeah, this is how you would want to write your answer if they ask for, the answer in this form. Quotient and remainder. Quotient is this. The remainder is negative 81. Rather than negative 81 divided by x plus 2, as we had in the second form right here, right? Plus 3 over 5. You don't want to write it like that. You want to write it like just like this. Okay. All right, I'll give you a sec to copy this, and then we'll talk about the division algorithm. Sam?
Why don't we do it like that? Is it just correct form?
Oh no, well, so this is just like one form to write it. So if you want to identify the quotient and the remainder, this is how you would write the answer. I mean, you could,
Oh,
if they don't specify, then you could write it like that. You could write it like, yeah, you'll see in the next problem, in the group work question. We're going to write it like the other form.
Thank you.
Okay, does anyone still need to copy this example? Okay, if not, then I'll move on to the notes for today. So here's the division algorithm. Actually, let me get to the slide for this. It'll be easier for copy. All right, here it is. Okay. Let me just make sure. Okay, yeah. All right. Sam, I don't know if you want to. I know you volunteered for the do now, but are you okay with reading this first part?
P of x and d of x are polynomials, with d of x not equaling to 0, then there exist unique polynomials q of x and r of x, where r of x is either 0 or of degree less than the degree of d of x, such that p of x is equal to d of x times q of x plus r of x, where p of x is the dividend, d of x is the divisor, q of x is the quotient, r of x is the remainder.
All right, thank you for that. So, yeah, the division algorithm there's actually more than just this division algorithm. There's others, like especially if you study computer science, you're gonna see other ways to divide. But anyways, this is the algorithm that we're gonna introduce in this class. And if you take math in college and take this class called algebra, so it would be like abstract algebra. That's like proving the things behind algebra. You're gonna use this theorem a lot. Okay, so yeah, here we have just p of x is the dividend, and I give the example here of the example that we just did. So 8x cubed minus 3x squared plus 2x minus 1 is the dividend. That's the thing we divide by. The divisor is x plus 2 in that case, and the quotient was 8x squared minus 19x plus 40. So that's q of x in this case. And then r of x is the remainder, which was negative 81. Okay. But yeah, this will be the main consequence of this, at least the one that we'll see in this class, is when we talk about synthetic division and finding the zeros. So as you can see, right, we can readily see one of the zeros of this polynomial here, like one of the x-intercepts, right? One of the x-intercepts is negative 2, right? Well, actually, let me take that back because there is a remainder. But if there was no remainder, yeah, if there was no remainder, then negative 2 would be an x-intercept. But yeah, in this case, there is not. So yeah, let me take that back. But yeah, you're gonna see it of the same form, like polynomials. It's gonna be a divisor times something else, and then that divisor is gonna end up being what we check to be an x-intercept. Okay. All right. But yeah, for now, just make sure you have this in your notes, and then we'll move on to the group work question. All right. Does anyone still need to copy this? All right. If not, then I'll move on to the group work. Okay. All right. So we have about 7 minutes left in class. So see if we can solve this problem. So 6x to the fourth plus 2x cubed minus x plus 2. and I want you to divide that by x squared minus 2x plus 2, and use 0x squared as a placeholder. So by that I mean, like, you see there's no quadratic term here in the dividend, right? So you should write in like plus 0x squared when you're dividing. But yeah, in the homework you're going to see like situations like that where, you know, some of the powers are quote unquote like missing, right? There's no like quadratic or linear coefficient, right? So you want to use placeholders to keep everything organized. And technically you don't have to, but I find it to be a lot more helpful if you do that. Daniel?
Yeah, so in test, are we gonna have questions that are specifically asking us to use division to use polynomial division, or do they like somehow like code it and it's implicit that we have to, it's like, so if we see a quadratic equation, when do we know if we should use division and or factoring?
Oh, yeah, so in this case, well, yeah, you'll see. I think they'll specify on Alex, but in this case, like, you're gonna want to use long division because like this would be hard to factor, I think, right? Yeah, I think this would, yeah. I mean, well, maybe actually this seems factorable, but like, yeah, you're gonna want to use long division here, just because like x to the fourth, right? So like, or like if you see something like x to the sixth, which you're gonna see on the homework, you're gonna want to use long division.
Thank you.
Yeah, but yeah, I think Alex would specify. Um, yeah, if this is on the next quiz, which yeah, I think it would be one of the questions there. So yeah, keep you posted. All right, so let me pause you here. Just want to make sure we have enough time to go through the solution. So let's scroll up. All right. So, all right. So again, I'm going to use 0x squared as a placeholder because there's no quadratic term here. So I just write that in, 0x squared. And you can also do this for the divisor as well. So like, for example, like if there's no x term here, if there's no linear term, then it's wise to like write in plus 0x, right? So you keep all the terms in order. Okay. Anyways, first thing we're going to do is 6x to the fourth, divide that by x squared. We're going to get 6x squared. And then what we're going to subtract from this polynomial is 6x squared times the divisor. Okay, so 6x squared times this is 6x to the fourth minus 12x cubed plus 12x squared. Okay, you subtract that, you're going to get 14x cubed minus 12x squared. Then you bring down the next term, you get negative x there. Okay, we're going to divide again, so 14x cubed, divide that by x squared, you get 14x. So we subtract 14x times this divisor here. So 14x times that is 14x cubed minus 28x squared plus 28x. So we subtract that, you're going to get 16x squared, right? That's negative 12x squared plus 28x squared. Then negative x minus 28x is negative 29x. Lastly, bring down the next term, right? Plus 2. And we're going to perform our last division. So 16x squared, divide that by x squared, you get plus 16. Subtract the product of 16 and the divisor. So 16x squared, and then minus 32x, and then plus 32. Subtract that. You're going to get negative 29x plus 32x, that's 3x. And then 2 minus 32 is negative 30. Okay. So note here I write the answer differently than the example that we did earlier, right? So here the quotient is 6x squared plus 14x plus 16, as we see here, right? And the remainder is 3x minus 30. And then I place that over the divisor, right? That's kind of like if I were dividing 5 divided by 3, right? The quotient for 5 divided by 3 is 1, right? So, and then you have a remainder of 2, so it'll be 1 plus 2/3, or 1 and 2/3, right? That's how we're writing it here, right? But if they just ask for the quotient and the remainder, the quotient would be this part, 6x squared plus 14x plus 16. The remainder will be just 3x minus 30. You would not write the denominator here. Okay. All right, let me close with announcements. One, there is SGI today, per usual, 2:47. Secondly, reminder that our next quiz is next Friday, so that's the 12th, March 12th. I'll send out the topics list over the weekend. I haven't made it yet, so I don't know if there's going to be a practice quiz, but I got to check out Alex if they have enough questions for that. Okay. All right, but yeah, other than that, if you're done copying this, you are free to go, and I will see you all tomorrow. All right, take care.
Thank you.
All right, you're welcome.
Thank you.
Have a nice day.
Thanks, you too.
Have a good day.
All right, thank you, you too.
Wait, so I have a question.
Yeah.
So when we were dividing polynomials, what we have to multiply the I think the divisor, right? The x squared plus minus 2x plus 2, right? We have to multiply that. We put that on top as the answer, right? Since we have to multiply x squared by 6x squared, so that would have to go up top, right?
The 6x word?
Yeah.
Oh, yeah, that one goes, that's the first quotient, so that goes on top. That's like, yeah, first part of the quotient.
All right, and you asked, like in the question, you asked for like quotient and remainder, but like what would like a regular test ask? Would it ask the same thing?
Yeah, well, a test could ask like either. So like those are like the two options. Like you could either identify the quotient and the remainder, or you could just not specify. In this case, it doesn't specify, so you would answer like this.
Okay, thank you.